Lesson 2, components. I snuck some of this in Physics 11 last year. Recall, I was only a scalar until you came into my life and gave me direction. Huh? Eh? No? Okay. We spent all of last day really talking about how you can answer example 1. A person walks 6 kilometers north and 4 kilometers east. What is their distance traveled? This we can do in our head. I hope Michael wasn't going to his calculator for that one. Michael, in your head, 6 plus 4 is 10 kilometers. No direction, because distance is a scalar. We spent most of last time, Ethan, looking at what if they want the displacement. I said anytime they give me compass bearings somewhere on the screen, I will put that, because the number of times I've botched east and west would astonish you. And we said we really want to add these two vectors together. How do I add two vectors together, Hedrick? Draw them. So I'm going to start out Dulp with a little picture. 6 kilometers north, Ethan, is going to look kind of like that. 6 plus, and I write a plus sign because we are adding. This is an equation. It's just a vector equation. 4 kilometers east. East is going to be to the right. 4 is a little smaller than 6, so I'll make my 4 a little shorter than the 6. Ethan, have you picked up on the magic phrase? How do I add two vectors together? Draw them. Here's what I really mean. Ready? There's the first vector. 6. See the tip of the first vector? The arrow? That's where the tail of the second vector is going to start. 4. There it is. By the way, Dylan, I would have no problem if you went 4 first and then 6. Do you notice the resultants we get are identical? It's just your degrees what of what will be the 90 degrees minus my degrees what of what. And where you have a south, I'll have a... Well, we'll talk about that, okay? We also said, and this is the really thing, I guess if you're going to memorize anything, Matt, the angle is always where the vector comes from. The theta goes there. A lot of kids want to put it up where it's pointing to. No, it's where it's coming from. And I'll call this displacement. The fancy name we called this, Taylor, was the resultant. Pythagoras, d squared equals 6 squared plus 4 squared. D is going to be 6 squared plus 4 squared equals square root. 7.21. Oh, I said to you guys last day, final answers this year, 3 sig figs no matter what. Units, kilometers. That's the magnitude. Now I need the direction. At. Until you get good, you might even want to start writing our handy-dandy trig acronym on the screen somewhere. Don't have to, but you might. That 4, opposite, adjacent, or hypotenuse. Opposite. What about the 6? Tan again. Usually, not always. In fact, definitely next lesson it won't always be tangent. I get tangent of mystery angle equals opposite over adjacent. The angle is 33.7 degrees. What of what? North of south, east of west, what of what? Okay, start out going north, go east of. Remember we said in our what of what, the non-slanty line appears after the of. So it's going to be east of north. And in theory, that was all review for you. In fact, I would consider that now a C or a C plus level question. To me, that's plug and chug. A little long plug and chug, but plug and chug. So Dylan, brush the cobwebs off after the weekend. How do we subtract vectors? You know what the short answer is? We don't. By the way, that's a bit of a fib. There is a method for subtracting vectors. You draw them tail to tail. And then the resultant is from the tip of the biggest to the tip of the... You know, rather than give you a whole new procedure, I think we can turn this into addition. What's 9 take away 5? 9 take away 5. Everyone? 9 plus what equals 4? 9 plus... You know, we can turn it into an addition if we just add the opposite. Why memorize a whole new procedure when we can tie it into one we already got? In vector symbols, we say this: vector A, take away vector B. If that's what you're wanting to do, you're going to go vector A plus the opposite of vector B, which means B originally pointed east. What would the opposite of east be? West. If vector B originally pointed north, what would the opposite of vector B? Yeah. The only thing now with subtraction, we have to be a little more cautious. What's 6 plus 5? What's 5 plus 6? Adding, we could be sloppy with order. What's 6 take away 5? 1. What's 5 take away 6? Not 1. So we have to be more cautious now. Okay? In other words, make very sure you know which one is the one that you're subtracting. Here. If F1 equals 6.8 newtons due west and F2 equals 12 newtons due north, what's F2 take away F1? I've turned the page. I'm going to do a compass rose. For subtracting, because it's a bit trickier, Priya, I almost always rewrite it. In other words, I'm going to say, okay, they want me to go F2 take away F1. I'm actually going to go F2 plus negative F1. This is how my brain is going to deal with this. Courtney, what's F2, magnitude and direction? Because now we're going to go to our DULP, our draw picture stage. Okay, so I'm going to draw a line 12 to the north. Good. Plus, what was F1 originally? In other words, Courtney, read me F1 magnitude and direction as they gave it to me. 6.8 west. What would negative F1 be? 6.8. Loud and proud. So I'm going to point to the right, is all. Okay? There. I turned it into addition. Even though that is the subtraction of the vectors in the original equation, hey, how would I add these together, tip to tail? So it's going to look like this. 12, 6.8. This vector right here is whatever you would get if you went force 2 minus F1. That's what you're going to get. How do I solve this? Yes, Pythagoras, again. Yes, SOHCAHTOA trig, again. In the interest of time, because I don't want you to have some time to work on the homework, I'm going to do the Pythagoras all at once, if that's okay. I'm going to go straight to my calculator. 12 squared 0.8 squared equals square root. I get 13.7. Oh, 3 sig figs. 13.8? 13.8 newtons at, where does the angle go? Bottom left or top right? The angle is always where your vector is coming from. Theta is going to go right there. And I've helped a few of you over the past couple of days. That's one area where people are struggling with. That's 6.8, opposite, adjacent, or hypotenuse. Opposite. That 12, adjacent, which trig function? Tan of mystery angle equals opposite over adjacent. Shift tan, 6.8 divided by 12. I get 29.5, oh, I guess 29.5 degrees. Goes on tight. Is that right? I made like 10 mistakes in the lesson this morning, which is why I didn't upload it. I was in terrible zone. So I'm nervous now. What of what? North of south, east of west, what of what? The of is going to be the straight line, so it's going to be of north. I find drawing that little arc helps me figure things out, and it takes 1 second. Then it becomes obvious I went east of north. Hey, let's do an actual physics-y application. Example 3. Oh, whoop. Very good. Whoop, 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 whoop. Earthquake. No? Okay. Sorry. Let's do a physics-y application. Who remembers from Physics 11, what is the letter P a symbol for? Oh, okay, so if final momentum equals 36 kilogram meters per second north, and initial momentum is 17 kilogram meters per second east, what is that delta actually a symbol for, that triangle? How do I find the change in momentum? How do I find, this is why I hammered that last year, how do I find change in anything? Final minus initial. And this time, Courtney, we're going to be subtracting vectors, and this is difficult enough. I'm going to go very systematic. I'm going to say to myself, by the way, what was another word for change in momentum? Who remembers? Impulse. Yeah, really what we're doing is we're finding impulse, but in 2D. A much more interesting car crash. Not a head-on, broadside. Okay? The impulse, or the change in momentum, is going to be final minus initial. Can you all look up for 1 second, please? Look up, look up, look up, look up, look up. Look up. Keep looking up, Priya. Look up. I'm going to go plus negative. There. I'm still subtracting, but I've changed the method for how I'm going to do it. If I can get this far, then really it's a matter of being very, very careful. But Braden got past the yucky spot. Braden, final momentum, magnitude and direction, please. Oh, for me, I've scrolled down. North, east, south, west. Final momentum, magnitude and direction, please. Read it right from the question. You're way overcomplicating it. What's momentum final? Psst, Braden. Yeah, final momentum, magnitude and direction.
36 kilograms.
Okay, so I'm going to draw a line north up, 36 long. You see what I meant? You're overcomplicating it, right? Yoink. 36 plus. What was the initial momentum before I mucked around with it? Magnitude and direction. Direction? So what will negative that be? Still 17, but so instead of pointing to the right, I'll point it to the left. Okay? 17 is about half of 36, so I'm going to put like that. Natalie, I want to add those two together. And I have turned my subtraction into adding now. Yes? How am I going to draw them? Tip to tail. Do you see it? Okay. I'm visualizing because, look up. I'm going to draw this and then go that way. I'm going to draw this not right here because I'll run out of room. I'll move this over here. I'm kind of imagining the triangle ahead of time. That's the next step now. You kind of visualize the diagram so you don't accidentally have to erase crap. So 36, yoink. 17, yoink. This resultant, which is always from the tail of the first to the tip of the second, that is the change in momentum. What is it? Let's get tricky. Let's do the trig. In fact, if you want to do this on your own, go ahead. I'll do this up here if you get stuck. Also remember the angle is always where it's coming from. So the change in momentum is going to be 17 squared plus 36 squared equals square root 39.8 kilogram meters per second at 25.3 degrees. What of what? North of south, east of west. What of what? West of north. And also, Courtney, remember, for each angle, there's always two answers. I would also accept 64.7 degrees north of west. How do I subtract vectors, Braden? I don't. With a bit of cleverness, change it into addition, because subtracting is the same as plus negative. Because also I put all my notes online, if you do fall behind and I scroll up, remember you can also find it on pitmath.com. You can copy it out later. So I'll come back to it later also in class if you need to, Paula, but I'm going to scroll up, okay? So we can always come back. Vector components. What we've spent so far, Matt, is I've given you two non-slanty lines and we've added them together to get a slanty line. I'm going to say we can do that backwards. I can give you the slanty line, you can give me the two originals it came from. The components. I snuck this into Physics 11 as well, a little bit. So we can break any vector up into its vertical, and I use the letter Y for vertical, and horizontal, and I use the letter X for horizontal, components. Find the vertical and horizontal components of this vector. So whenever I talk about vertical and horizontal components, we're going to assume we're looking at this from the side. They're launching something up at that, and I'm looking at it from the side. Okay? Well, first I'll draw them in. There's Vx. There's Vy. Why did you use the letter V? It's meters per second. I'm pretty sure it's a speed or a velocity. This time, Taylor, no Pythagoras, because you can only use Pythagoras if you know two sides. Find the third. This is going to be straight right-angled trig, or SOHCAHTOA, if you use the English acronym. I think I said this last day, but I'll repeat myself. For my ESL students, I don't know what the words for sine and cosine and tangent are in your language, but they should be close, I think. Like, I think tangent begins with a T in most languages, and cosine begins with a C in most. I think we'll be okay. If not, ask me later, and we'll do some Google Translate. Hey, John, the 42, opposite adjacent to hypotenuse. Yeah. What about Vx? Yeah. What about Vy? Okay. Let's find Vx. A and H. Which trig function, John, my friend? I agree. Cosine, what always goes next to there? The angle. Now, up until now, I've had a theta there, but this time I know the angle. Equals Vx over 42. How would I get the Vx by itself, my friend? The 42 is dividing the Vx. How could I move it over? I agree. So if I hear you correctly, I think I do, you're telling me that the horizontal component is going to be 42 times the cosine of 38. 42 times the cosine of 38. 33.1? Hey, which trig function could I use? Which trig function could I use to find Vy? Sine. By the way, I guess I could also now use tangent since I know Vx, but why not use what they gave me to find something else and hedge my bets a bit, right? So sine, what always goes next to the trig function? The angle is Vy over 42. Mr. Dewick, will Vx always be cos and will Vy always be sine? Often, but not always. And that caught some kids in the homework this time. If you want the long answer, if your angle is touching the ground, like the 38 is, then yes. But if they give you this angle here, then no. So do the trig, at least part way until you're sure. How would I get the 42 over? Yeah, okay. So Vy is going to be 42 sine 38. $25.85, how about 25.9? Now, if I was going to use these, Dylan, to find something else, I would carry extra sig figs, but they just said find the components. Okay. Is that all right? Yeah? Try example 2 on your own. I'll do it up here. If you feel comfy going fast, taking shortcuts, whatever level of comfort you're at, that's fine. So I'm going to do it up here without talking. Find the components of this force. Am I right? Yes? Okay. Again, Matt, if in your homework you're getting good enough at the trig that you can show less work than that, go ahead. And you've had me enough to know my next question. But would I take shortcuts on a test? No. I show all my work on a test or a quiz because I don't want to make mistakes. But part of taking shortcuts is part of becoming expert. Sure. Is that all right, Court? Where can we use this? Components can help us add vectors that are not right angles with each other. So I would consider this question here now, adding those two together, a C-level question. I would consider subtracting two vectors a C plus or a B minus level question. You ready for an A level question? And there will be one like this on your test. Ugh. How can I tell at a glance this one's going to be yucky? Because there's angles in the question, which means this is non-right angle. As soon as I saw that 30 degrees south of west, ugh, that bumps this up a notch and a half. This is a level A question. They want us to add 12 newtons due west and 24 newtons at 30 degrees south of west. This is also going to answer Paula's question earlier in class from number 13 and 14 from the last day. This will actually help you answer that too. So I knew this was coming as well. Well, are we adding or are we subtracting? What's this question want us to do? Add or subtract? You know what? I'm going to put a plus sign because now I feel better. Oh, and Ethan, because I see direct compass things, do that because I've turned the page. Ethan, can you read vector, magnitude, and direction, please?
14 west.
14 west. West is left or right? Okay. This next part is the tricky part. This next part is where you really want to pay attention. Dylan, can you read to me the second vector, magnitude and direction?
24 degrees at 30 degrees south of west.
South of what?
West.
South of what?
East.
No, I just want you to keep repeating yourself. Ready? South of what? No, I don't want the south of. You ready? South of what? South of what? South of what? That's what I'm going to draw first, the of. South of what? Look up, look up. South of what? I'm going to start out with a dotted line to the west. This is how you draw these. Okay? Dylan, what of west? So starting here, am I going to go up or down? Down. South. How many degrees? I'm going to eyeball it. That's how you draw that. Oh, mine should be a bit longer, though, because if that's 14, 24 would be about like that, I guess. Okay? Your lap, by the way, to this day, though, that's still how I do these. In my mind will say, south of what? South of what? That's what I'm drawing first, the of blank. Because the big question, kids, are, which one do I draw first? You okay with that? Am I adding these? I could add these tip to tail. It would look like this. There's the first vector. There's the second vector. Don't write this down. There's the resultant. And you can solve that with the sine law or the cosine law. And if you're good at the sine law or the cosine law, I am. You can do it that way. Or we can break the yucky one. Ethan, which one is the yucky one? It's pretty obvious, yes? This into components. I can go like this. What are these? Forces. I can break this up into Fx and Fy. Why is that so nice? Because now, Sarah, once I do this, I can combine the horizontals into one and then just add the vertical. Instead of doing three separate vectors, first of all, instead of doing one slanty vector, I can turn it into two nice vectors and then combine them. Hey, Marcus, Fy, oh, sorry, 24, opposite adjacent to hypotenuse. The 24?
Oh, 24,
hypotenuse, yes. What about Fy? What about Fx? Okay. I'm going to do the trig part over here, and then I'll fill them in onto my triangle. And because I know I'm using these for more answers, I'll carry extra sig figs. Okay, let's find Fx first. Marcus, Fx, which trig function? So it's going to be cosine of 30 equals Fx over 24. Natalie, how would I get the Fx by itself? If you want to right now go straight to your calculator and go 24 cos 30 without writing that down, I'm fine with that. If you're comfortable doing that, and it sounds like you are, I'm going to put 20.785. You know what? How about 20.7846? 20.7846. That's lots of extra sig figs. That'll guarantee that I'm accurate to my 3 sig figs at the end. Adrian, which trig function am I going to use for this one? You okay? Which trig? Which trig function is it in your language? Is it Zenos? Sine?
What?
Trig function? Sine? I'll get you later. Sorry. I apologize. I thought I had you with me. My bad. Sine, yes? Yeah? Sine 30 equals Fy over 24. Yes? How would I get that by itself? Just times the 24 over. If you want to do that straight on your calculator. Eric, put your phone away completely for the remainder of class, or I'll take it away. Thank you. Yeah, I saw it. Hey, the nice thing about the smartphones getting bigger and bigger and bigger, it's harder and harder for you guys to hide those things. I mean, 2 years from now, you're going to be lugging a monitor around, right? I'm not texting. Yeah, whatever. This works out evenly, I think, yes? Oh, sorry, 30. It doesn't work out to 12, bang on? I know sine of 30 is 0.5. So this works out to 12. So now we're coming back to Paula's question from the beginning of class. What I'm going to add is this, this, and this. Except I'm going to get rid of those circles because that's really cluttering up my diagram. I'm going to add 14 west plus 20.7846 west. In fact, I can do that in my head. 34.7846. Yes? Yeah. And they are in a straight line with each other, so I don't need to go tip to tail. I can just do the math. Or if they were in opposite directions, I'd go Priya, winner minus loser, which isn't that big a stretch either. Okay? So it's going to go like this. 34.7846 and 12. And Michael, I'm going to argue that's a much prettier triangle to do math with than 14 plus that and that. Again, that one is totally doable. And if you're good at the sine law or the cosine law, great. Or if you come in on a flex blocker after school, I'll show you how to do it that way. In fact, I'll be honest, I tend to do it that way because I'm really good at the sine law and the cosine law. I can do them both in my sleep. I have them all memorized. I don't have to look them up. I'm good on my calculator. But if not, we can tie it into something we already know. As always, Taylor, it's going to be from the tail of the first to the tip of the second. This is going to be F resultant. And now it's going to be Pythagoras and SOHCAHTOA trig, right angle trig. F squared is going to be 12 squared plus 34.7846 squared. 12 squared, 34.7846 squared, square root. 36.8. Now I'll go to 3 sig figs for my final answer. 36.8. Newtons at theta goes here. Opposite, adjacent. Tan theta equals opposite over adjacent. Opposite over adjacent. And I get, I guess, 19 degrees even, 0.0, 19 degrees. North of south, east of west, what of what? This is going to be south of west. Or I would also take 71 degrees west of south. But I gotta be honest, this is the first year I'm showing the component method like this. Normally, I really push my kids to get good at the sine law and the cosine law. I've had a couple of my engineering students tell me in post-secondary that the profs really emphasize the component method. Okay. And I guess if you get really good at right angle trig, probably, John, you could skip a lot of steps and actually do a lot of it straight on your calculator and just make a few jots and get really good at it. Okay. In my answer keys, you'll probably still see I use the sine law and the cosine law because, you know, math nerd. A couple more, we're done. Well, this is the upper level of how tough a question I'll throw at you. How can I tell Braden at a glance that this is a yucky question? I see degrees in the, see the 40 degrees? Not right angle. Ugh. A plane's speed is 240 meters per second due east. A crosswind is blowing at 125 meters per second, 40 degrees north of west. What's the plane's velocity relative to the ground? You can see this is a useful question if you're doing, I mean, certainly for planes, this helps you figure out your ETA. Okay. I've turned the page. I'm going to do that. By the way, if you're wondering what we're saying, Courtney, we're really saying this. The velocity of the engine plus the velocity of the wind is what gives you the velocity of the ground. In other words, Courtney, I think we're going to add these two vectors together. And I'm not going to jump straight into drawing them tip to tail because I see a yucky, see the yucky angle, Priya, the 40? Okay. Priya, can you read to me the plane's velocity, magnitude, and direction? East? Okay. Yep. Plus. Can you read to me the wind's velocity, magnitude, and more importantly? Yep. North of what? North of what? North of what? What am I going to draw first? Same answer. North of what? What am I going to draw first? I'm going to go like this. West. What of west? So I'm going to tilt up. How many degrees up? Yeah, about like that. 40 degrees. And I did the 125 about half as long as the 240 because 120 is half of 240. Close-ish. Priya, is there a slanty? Ugh. Now, again, you could go tip to tail, and that's the resultant. Are there any right angles in there? You can do it sine law, cosine law. Or we can take that slanty and find components. You can find components. We can break it up into Vx and Vy. Vy opposite, Vx adjacent, 125 hypotenuse. I'll zoom in so you can see better because I drew that triangle pretty small. Let's do the horizontal first. Priya, which trig function is going to give me the horizontal, kiddo? I got A, I got H. Yes? And again, if you're not sure, you write SOHCAHTOA at the top of the page, right? Cosine of 40 equals Vx over 125. Priya, how will I get the Vx by itself? So I'm going to do that all on my calculator if you're okay with that. 125 cos 40. And I'll carry some extra sig figs, so I get 95.7555. I'll go 95.756. I figure 5 sig figs will be okay for 3 sig figs in my final answer. Priya, which trig function can I use to find Vy? Yep. Sine of 40 equals Vy over 125. Are you saying that I would times the 125 over? Are you saying I can go straight to my calculator? I'm okay with that. On a test, I would never do it this fast. And I get 80.348. 80.3848. That works. Equals 80.348. And now I got to zoom back out again, okay? Boom. Priya, can you see? I think I can add these two together pretty easily, except are they in the same direction? I'll go winner minus loser. Is that all right? Can you do that on your calculator? So it's going to be 240 take away minus 95.756. I get 144.244. Anybody else? Yeah. Which way?
West.
Still west?
Oh, sorry, east.
I think east is winter, yes? Okay, so now I can change this question into 144.244 plus 80.348. And this goes back to your earlier question, Adrian, how would I add three vectors together? I'd combine the ones in a nice straight line first, make that into one vector, and then add the third one. Is that all right? Hey, how will I add these two? Draw them tip to tail. Now we've turned this yucky question into a C+ question. Just took some work to get there. It's going to go 144.244, 80.348. There is the resultant. This is the ground velocity, VG. Pythagoras. I get a magnitude of 165.1, I guess to 3 sig figs now, 165. The ground velocity is going to be 165 meters per second. Is that right? Yeah. And then it's going to be opposite, adjacent, tan of mystery angle is 80.348, 144 point. 80.348 over 144.244. 29.1 degrees. North of south, east of west, what of what? I think it's north of east. I wanted to do one more. We're going to pause. I want to give you at least some time to work on this. And then we'll also continue some of this next class. I think next lesson will be shorter. Okay? Yeah. So for now, this is not due next class, but it'll be due the class after, and you might be getting some more stuff next class.